More than $1 trillion has been pumped into the development of artificial intelligence, but it has many internet users and economists on edge. They're very worried that instead of AI being the next big thing for all of us, it might be a bubble waiting to burst.
Here's what almost every news story about the AI cycle gets wrong. And I'm not talking about the technology or even the timelines. It's something so fundamental that once you see it, the entire story changes. And it's hiding in plain sight inside the fabric of every data center being built right now. But before I answer that, let me quickly set the context for you in under a minute. Ever since ChatGPT launched in 2022, every major technology company on earth declared artificial intelligence its primary strategic priority. And declarations at that level require infrastructure. Hence began humanity's largest ever construction project for the most critical asset of the 21st century, AI data centers. And total investment in this asset class is projected to reach $7 trillion by 2030. That's more capital directed at a single technology build-out than the space race, the interstate highway system, and the entire history of the internet combined. In fact, a McKinsey report in April 25 called it the $7 trillion race. It became the number that justified everything. The investments, the announcement, the construction, and all the news headlines are treating the entire AI infrastructure build-out as one thing. One project, one number. But here's the question nobody is asking. What if that number, the one underpinning the biggest bet in human history, is still not enough to build what AI actually needs? To understand why, we need to understand something about data centers that almost nobody is talking about. Not what they do, but the structural flaw buried inside every single one of them that no amount of money can fix. Let's get right into it. The thing with AI data centers is, it is not one machine. It's three machines layered inside each other. Each one serving a different function, each one built on a different timeline, and each one running on a completely different clock. And this right here is the heart of the problem. Let me explain that to you. Think of it like a car engine with three components that all need to work together. The engine itself, the fuel system that feeds it, and the road infrastructure that allows it to move. Each one is essential, each one is built differently, and the car can only go as fast as the slowest one allows. Now apply that to AI infrastructure and watch what happens. For that, let's bifurcate the AI data center into three parts: Zone 1, 2, and 3. Zone 1 is what everyone talks about. The GPUs, the chips, the high bandwidth memory. This is the raw processing power. The part that actually runs every AI model. Think of it as the engine, and right now, 60% of all AI infrastructure spending goes here. And it moves at an extraordinary speed, with a refresh cycle of 2 to 3 years. Which means the chips available today will functionally be obsolete in the next 24 months. Not because they stop working, but because the next generation will be so much more powerful that running last year's hardware becomes economically indefensible. And here's what the speed actually means in practice. And this is the part that should alarm you. You're not building an asset when you buy these chips. Rather, you're feeding a trade mill. Because every 2 years, you have to buy the entire stack again, just to stay competitive, just to maintain the same relative position you had before. If you come to think about it, by year 4 of a 5-year infrastructure plan, nearly $2.5 trillion of that $7 trillion would be spent not on expansion, not on new capability, but simply replacing Zone 1 hardware that has already gone out of date. And here's the deeper problem with Zone 1 that you should pay attention to. The demand it creates is not linear, it's recursive. Let me explain what that means. The thing is, modern AI doesn't just run. It generates demand for more AI. Models that are more powerful creates applications that require even more powerful models. The appetite compounds, and every upgrade doesn't really satisfy this trade mill. It just speeds it up. So the 60% of the $7 trillion allocated to Zone 1 is not a fixed cost. It is a growing one, and it grows faster than any budget projection can comfortably account for. Then we have Zone 2. Zone 2 is the central nervous system of the entire operation. Think of it as three things working together. The networking fabric that connects every chip to every other chip, the cooling infrastructure, because without it, the heat alone would shut the whole thing down. And then you have the optical interconnects, which carry data between racks at the speed of light. This layer takes 3 to 5 years to properly implement and represents about 18% of the total budget. And something has happened to Zone 2 that nobody really planned for. Something that has tripled in cost and blown its budget allocation completely out of proportion. Here's what changed. Traditional data centers were built for a simple relationship between a user and a server. You send a request, the server responds. Engineers call this north-south traffic. It flows in one direction. It's clean, predictable, and relatively easy to architect for. But modern AI doesn't work like that. Think about what is actually happening inside an AI system today. A model doesn't just respond to your query. It calls other models to verify your answer. It orchestrates multiple agents simultaneously. This is what engineers call east-west traffic. GPU talking to GPU, model talking to model, not in one direction, but every direction simultaneously. The networking infrastructure being built for a world where AI served users cannot handle a world where AI talks to itself at that volume. The bandwidth requirement now are not just double of what was planned, they're not even triple. In some configurations, they are an order of magnitude beyond what the original architecture anticipated. Zone 2 has tripled in cost as a result, which means the money that was supposed to build the nervous system is running short. And a data center without a properly built nervous system is not a slower data center, but a broken one. And then there's Zone 3, the zone that makes the first two look easy. It consists of the electrical grid, the building shell, the land, and the permits. It is essentially the ground that everything is built on, quite literally. It accounts for 22% of spending and has a 15 to 30 years refresh cycle. And the thing with Zone 3 is that it is neither a technology problem, nor an engineering problem, or a money problem. This is a physics and time problem, and it is the hard ceiling on the entire AI economy. Because no matter how fast Zone 1 moves, no matter how urgently Zone 2 is being rebuilt, Zone 3 will not be rushed. And understanding exactly why is what makes the wall we are about to hit feel genuinely alarming. I'm not sure if you know this or not, but the current AI build-out requires an estimated 6 million labor years of skill construction work. Right now, there's a global shortage of 439,000 specialized electricians. The apprenticeship to become one is 5 years. This is not a policy choice nor a regulatory inefficiency. It is the minimum time which is required for a human being to develop that kind of expertise. And this is just one layer of the physical constraint. Think about what it actually takes to build the power infrastructure for a single large AI data center. You need a high voltage substation. And the lead time for a new substation in primary infrastructure hubs is currently between 24 to 36 months. That is because the electrical transformers at the heart of every substation are themselves in shortage. The factories that manufacture them are running at full capacity. The supply chain for the specialized steel they require is completely backed up. And the permitting process that governs where and how they can be built was designed at a regulatory pace appropriate for the 1950s. Nobody has updated the process for a 2026 construction emergency. The thing is, we are trying to build 2030 scale infrastructure through a 1950 scale regulatory system, with a workforce that takes 5 years to train and using components with a 3-year manufacturing queue. And here is where Zone 1 and Zone 3 collide in the most expensive way possible. Think about it. Right now, the largest technology companies in the world are buying Zone 1 chips or GPUs at a 2026 pace. Hundreds and thousands of them, completely paid for, committed, and delivered. For buildings that won't have Zone 3 power up until 2028. And while they wait, the clock on their obsolescence is running. You remember Zone 1's 2-year refresh cycle? By the time the power arrives and those chips can actually be switched on, they may already be a generation behind. The infrastructure built to house them may be designed for a chip architecture that has already been superseded. And this is not a theoretical risk. It's happening right now at scale across the AI infrastructure build-out. Now zoom out and look at all the 3 zones together. Zone 1 is racing ahead, consuming 60% of the budget, spinning faster every cycle, generating demand that compounds on itself. Zone 2 is scrambling to keep up, its budget already blown, its architecture being rebuilt in real time for a traffic pattern nobody anticipated. And Zone 3 is barely moving, constrained by physics and regulation. So 3 gears, 3 speeds, 1 whole machine. And the machine can only move at the speed of the slowest gear. And this is not a temporary bottleneck that more money will resolve. This is a structural mismatch baked into the fundamental architecture of what is being built. And the people building it know it. Which is why, if you look into what they are actually doing rather than what they are saying, the picture looks less like confidence and more like controlled panic. Watch the behavior, not the press releases, because everyone's trying to act cool right now. The thing is, when companies are confident in their supply chain, they negotiate carefully. They take time and optimize for price. When they're afraid, They move fast, they overpay, and they structure deals that would have seemed extraordinary just a few years ago. Look at what's been happening. In September 25, Nvidia, the most dominant company in AI hardware, sitting on roughly 80% market share, invested $5 billion directly into Intel, a former rival and a company that has spent the better half of the decade being completely written off. Ask yourself why the most powerful chip company in the world would do that. Because even Nvidia is not immune to the constraints we just described. The $5 billion investment is not generosity. It is insurance against a world where the slowest clock creates bottlenecks that money alone cannot solve. OpenAI has locked in multi-year GPU supply from Nvidia, AMD, and Broadcom simultaneously. It has received warrants to purchase 10% of AMD's share, embedding itself as a strategic shareholder inside the supply chains of its own suppliers. Think about it, an AI software company has made itself a part owner of the semiconductor manufacturer it depends on. Read that not as ambition, read it as fear of running out. Every one of those deals is a company saying in the most expensive language available to it, we are afraid of what happens if the gear stops turning. Now we arrive at the question this whole story has been building towards. Is any of this really going to work? The honest answer is nobody knows. And anyone who tells you otherwise is selling something. But here's what we do know. In September 2025, Deutsche Bank concluded that without AI-related investments, the United States economy might already be in recession. When an economy's health depends on one bet not going wrong, that is not prosperity, that is exposure. And then there's geopolitics. Both the United States and China have declared AI a matter of national security. India's AI mission is framed as economic sovereignty, the recognition that depending on others for AI infrastructure carries the same strategic risk as depending on others for food and energy. Sovereign strategy does not respond to market corrections the way venture capital does. And the floor under this investment cycle is not just financial, it is political, strategic, and in some ways civilizational. See, the thing is, every infrastructure bet in history has looked at some point during construction like it might have been a mistake. The railways nearly bankrupted the companies building them. The power grids were called reckless overinvestment, and the internet was dismissed as a fad for academics and enthusiasts, before it rewired every economy, every relationship, and every industry on the planet. The question is never whether the physical world pushes back. It always does. The question, and the only one that matters, is whether what gets built on the other side of the resistance is worth it or not. The gap between what we have declared and what the physical world has allowed so far is the central tension of the next decade, and you and I are living through it.